Okay, I think we are live. The stream might take a few minutes to catch up with what I'm streaming right now. Okay, so in my previous video there was a lot of drama. The previous stream got struck down by YouTube as spam, and later I realized it was not just my stream, but there's like a bunch of other people's streams was being set to private as well, and it turns out it was an error on YouTube's end, and they've reverted it, thankfully. So the video should be out. That was the 6th video, and also in that video I did a lot of mistakes, silly, stupid mistakes, basically. I muted the audio and forgot to turn it back on, and then I was explaining something without showing the screen. So I just want to revisit that a little bit, and then we can proceed with the rest of the questions. And I'm not sure if I want to go through the hard questions at this point. Perhaps not. And the original goal of this stream was not to write the code. Hey, what happened? Like the beautiful, yeah, it's the sometimes just Jamboard magically disappears things. Anyway, so what I was saying, yeah, so there was some mistakes, and I probably briefly touched what was I was muted in the previous video. Maybe I should rephrase what I just said. Maybe I should explain the portion where I was muted in my previous video, and then we proceed with the next questions. But we might change the gears a little, and I won't be writing code. And one of the things I realized, I quickly jump into writing codes even though I'm trying to explain something, and maybe it's a good thing, you don't get to write or theorize anything without writing code. That could be it. But maybe you could trace it for instance, you would understand what I'm saying by if you go back to the previous question, where I'm still getting used to it. It's still not obvious. So the part where I got muted was when I was explaining why we need a while loop instead of if. That was here before this, and the reason for that is let's say your pointer is here, your end pointer is here, and your start pointer is here. And then if you do and in the next iteration the pointer moves here, so the count so far is 3 A's, as I wrote down here. So let's write down 3 A's and 1 R. So it meets our criteria. There's only 2 distinct characters, and then everything's fine. But the moment the end pointer moves to here, C becomes 1. There are 3 characters, but if we just move the start pointer by 1, A would just decrease by 1, and you'll still have 3 distinct characters. So that's why the if is not sufficient. We have to do a while loop and then correct it until A completely goes, or in this case we don't need to A to completely go, either A to completely go out of the window, or in this case R goes out of the window before A does. If let's say this was A, and A would have completely go off, I mean we wouldn't have the problem, because anyway, so that was just an example. So going back to the problem, so when we are here and when we just do if, we wouldn't the count will be still 3 distinct characters. A would have just decreased by, but if you do a while loop, it'll try to decrease, move to the next one, and then since we are removing r becomes 0, and then it terminated it, so 2 a's and 1 c. So this would fit the condition, and we'll proceed with the next loop. So it'll work as another thing that I was explaining is the refactoring part. So there's like a lot of repeating conditions. If then len of d is equals to k, then only consider it. If it's not, then don't consider it. I'm gonna take this off because it's kind of echoing in my ear. This is not an expensive mic, so there's still a lot of latency, and that's keep second guessing what I'm saying. I'm hearing the echoes of it. It's not pleasant. So anyway, I should probably keep these meta conversations to minimum, because that distracts my flow, and it's kind of difficult to handle these in order to avoid meta discussions. I'm talking more about meta discussions. Here we go. So it's not me just explaining the code. Like, I've done this mistake a couple of times. It's not just that. I have to make sure the stream gets there, and then the audio is fine. I'm not muting or doing some dumb shit, and then I'm sharing the right screen. So there's just more than what the interview is. So it's something I have to be mindful of moving forward. And I tend to make these kind of mistakes, especially when I'm sleep deprived, like I was in my previous video. But I don't think that's gonna change anytime soon. So it seems like we have got a viewer. I hope. Yeah. I hope you come in peace. So anyway, so that was it, and it's okay. So another thing I realized, I was jumping into code. I was jumping into the code without thinking through the solution. And another second thing I noticed was I tend to write a lot of if conditions that can be merged and refactored into a single block if you just at a like, what do we say, at a optimal code. But it's fine. Like, even if we've got like multiple if and else, once we write down that code, we could probably refactor it. Hey, this is something. And another thing that I kind of underplayed in my previous video was this is a kind of a logical error. This is a logical error, and this is kind of the error that you should be very aware of. It says no more than 2, so it doesn't mean that it has to be exactly equal to k. So it has to be less than k, or k less than or equals to. So that's what this thing, if you if you could describe that, that's what that thing's supposed to refer that. So this is a logical error, and I have to be very mindful, because these are the kind of things that easy to get wrong when you are doing something under stress. So let's move on to the next question. The next question is kind of follows a similar trend. So the entire series that we are doing right now is based on one theme, that is the sliding window. I don't remember if I've already explained this before, but that's the theme of problems that we're tackling. And ideally, I should be doing this at a much faster rate. I'm supposed to cover like 11 different topics within a day, but at the rate that I'm going, it probably takes 7 years or 11 years. That was not a statistical estimation. It was just random estimation that it came up, the random number that came to my mind. Anyway, okay, let's move to this question. So, fruits into basket. We have got different fruits, and you can put 2 C's in one basket and 1 in A. I don't remember this question. What is this about? Give me a second. You can put 2 C's in one basket and 1 A in the other form of subarray. Okay, I don't remember what this is about. Okay, so the question is, given an array of characters where each character represents a fruit. You're given 2 baskets. Your goal is to maximize the number of fruits in each basket. The restriction here is each basket can only have one type of fruit. It sounds like a dynamic programming problem, where you have to maximize. So you've got like a couple of trees, and then you have to pick the fruits. I've got two baskets. So the k here is fixed, is 2. So you're given 2 baskets, and you have to find maximum. You have to find a way to maximize the number of fruits in each basket, and each basket can only have one type of fruit. So here we put 2 C's in one basket and one in other. Okay, and then it has to be a sub array. This is interesting. Okay, so and there's another restriction. So this question is very poorly written. So you can start with any tree, but once you have started, you can't skip a tree. So it has to be a contiguous subarray. In that sense, so you have to pick a subarray. So now it becomes like 2 pointers. Since you have to just pick a subarray, the problem becomes a bit reduced, and we could do. So how will we approach this? There's one way, the always tested and proven way of using brute force, which would work in any case. Give me a second. Right. So that would work in any case. But can we do better? As the title says, we could use a sliding window approach where we maintain 2 pointers, and then as we move out of the window, we remove things and add things. Okay, so that's that. So actually, this problem is very similar to the previous problem with k distinct characters. So here we want 2 distinct characters. Yes, we basically want 2 distinct characters, and then we want to maximize that. So here we want to maximize longer substring. So it's kind of similar, just worded in a different manner. Instead of a string, it's just subarray. And this kind of mapping or reducing the problem and realize like what. So this was slightly different. It took me a while, but I'm not sure if I even telling you this right, but it seems like it's the same problem, but it's just worded differently. But I could be wrong. Can put 2 in the basket. So yeah. So all we need is like distinct characters can be 2 in one, and longer subarray. Yeah, it seems similar. So the algorithm for in this case, so that we have, I'm not used to this yet. The algorithm is A, B, C, A, C, 0, 1, 2, 3, 4, and we start with starting pointer. And we use ending pointer, and the dictionary of the distinct characters here. So we will loop until the dictionary becomes more than 2, and then when it does become more than 2, the size of dictionary becomes more than 2, we start increasing the size, increasing the index of start pointer. Okay, so for that, let's trace through. So the dictionary length is 0, so we increase it, and then Actually, in the first step, we need to add a, and then add 1. I mean, someone's watching, and that's kind of stressing me. I hope you don't mind me just blabbering. So yeah, where was I? We start, and then when we move the pointer, we start with the pointer being at index 0 and move to 1, and we add the count, and then so it still meets the character. It's less than 2, no, less than or equals to 2. So then we move on to the third one, and then we add C. Then the condition breaks, the base condition or whatever condition you can call it, it breaks. So in that case, what we do, we move the pointer by 1. So start pointer moves to here, and we remove A. And where do we evaluate the answer? So here we're moving windows, but are we considering the outputs? No, I'm not. So if we move here, the maximum that we can put now is 1, 2. So we just sum up these two things. So the max so far, we could probably evaluate it at this stage. It would have been 1, 1, 1, and then now when it's at this stage, at this stage it would have been 2. Yeah, when S is here and E is here, it would have been 2 distinct. So max would have been 2, and when E moves to the next, and then realize the S is not meeting the condition, the S would move 2. Then it will be still 2, so there's no change. And then when the conditions are met, and then we move E again to here. In that case, how many characters? So we add A again. A equals to 1. It fails the character, so we move the starting pointed by 1, and then we would still have 2, and then E moves to the rightmost, and then if we consider now, so when we move the S, we have to remove the thing from the dictionary, and we move the E, and we realize there's another C, so we add 2, and now if we count this histogram count, it's 3, and that's the end of it. So when E reaches max, end of the array, we take the max, return the max. So in this case it's 3. So that would be the algorithm for these. It's pretty very similar to the previous one, but let me check what these fellas have put it in. Yeah. Yeah, okay. Actually, yeah, we don't even have to count this. Yeah, this is something that I didn't realize. We don't actually count the number in the histogram in the dictionary. We could actually just use the same methodology that we used in previous. So to count the number, the maximum number, which is the output that's required here, by using ending pointer minus starting pointer plus 1. So in this case, ending pointer is at 4. 4 minus 2 is 2 plus 1, 3. So we get the answer. Everything else remains the same. Good job. I did a good job. I hope you don't mind the background noise. There could be a lot of background noise since I'm doing it outside my regular working hour of 1 a.m. to 4 a.m. I'm doing it now at 6 a.m. 6 p.m. I'm supposed to start earlier, but I got distracted with a lot of things that's going on in the stock market. and Elon. So, and also I've got like a poor uh, discipline. That's another honest factor. Okay. Yeah. So I was telling you about how I do these stupid things, right? So I just muted myself, and you probably didn't hear what I was saying. That's because I muted my phone because there's like a lot of background noise. Yeah, these things might take a while for me to get used to. So the problem here is finding the longest substring with non-repeating characters. That's the problem. And what I was saying was, if we didn't had this pattern or mentioned, it's not all that obvious that I should be using sliding window pattern to solve this problem. Um, because yeah, longest substring. Maybe the keyword that would help you to think about sliding window pattern is probably longer substring. Um, maybe. Okay. So let me check the stream. Yeah, everything looks decent. Um, and I'm not muted. Okay. So how do we approach? First off, A, B, C, C, B, B. 0, 1, 2, 3, 4, 5, 6. Okay. And we start with the pointers because we know this is a pointer problem. This is a start and end non-repeating substring. So it probably is similar to the previous questions where I used hash tables or dictionary in our case to keep a count of like the character that we already seen, and when we see a character that's already in there, we downsize the starting window. Or okay, let's trace through. So and if you notice, we're not writing code here. I just walk through the algorithm in my mind, and then I check the solution on my other screen and see if the algorithm kind of fits and if I miss any nuanced details. So this practice would probably to help you to figure out or train your brain. This is my hypothesization, my hypothesis. I'm not sure if it's scientifically proven, so don't take anything that I say. It is my perspective. So anyway, I think yeah, reading the solution or right away does not make you feel the intensity of problem. It makes you overestimate your abilities and underestimate the problem's difficulty. So what I suggest is come up with your own algorithm in your head. You don't have to write it down. It doesn't have to cover all the edge cases, but still um, write it down the overall algorithm and then look at the solution. If you want to really speed up things, you don't want to like take the hard road of like writing down, submitting to Leetcode, let it cover every edge case. If you don't have the luxury of time, you could do this method. There was someone else on Reddit who suggested that they were incredibly. So this was a new grad on Reddit who was boasting on Reddit that he got so many offers from Fangs, but the approach that he took to study these lead code problems was look at the problem, look at the solution, and repeat. Keep on doing and until you understand the solution, and once you're fairly comfortable, start doing it then. Because I kind of agree with that approach. Like, not a lot of these things come naturally to you, and whatever the algorithm that you have in mind, or some easy problems like login. There was a string switch problem that was marked as easy, but this optimal solution for it was like some optimization, someone's thesis from 1970s or something. It's actually a research paper level, and they expect us to code that now in 10-20 minutes. So that kind of expectation is unreasonable. So and it might make you to overestimate your abilities and overlook the complexity and nuanced uh, nature of these kind of problems. So going back to what we have in front of us, the longest substring with any repeating character is ABC, C and E. Okay. And again, we have to maintain some sort of dictionary to make sure that we once we see, I don't know what we're gonna do once we see a character. Let's walk through. So we're gonna see the histogram. So the moment we scale down or move, the condition in this case would be D. Every item in D should. So if E item array on E should not exist in D not. So the element must not already exist in A. Then we know it's a unique string, non-repeating characters. So this is the base case. So we add A, and then so we're meeting the condition, the base condition. We move E. Maybe you can write E's, and then but now the character is already in the dictionary. So what we can do, we can move S to here. We can move S to here as well, and then we usually remove and then write back again because the current character is A. So write back, and then now the condition is met. Then we move pointer to E, and then we add B, so the condition is met. There's no repeating characters. Then we move on to the next character, E, add C equals to 1, count is 1, the condition is met. And all this while, so we again, what is the condition that we should keep? So max non-repeat is we can start with some really negative infinity initially, and then it would have been like 1 after that, and all this while. And then here, if you see, it will become, so once we move to E to B, the number would have been 2, because A and B are 2 strings, 2 distinct characters, and the maximum non-repeating characters length is A and B so far. And then once we move that to C, it would have been 3. That's the maximum so far. And then we move to the next character, E, and we realize the last character is still there. So what we do, we have to reduce the string until we get rid of the duplicate. So how we can do that? We have to jump all the way from here, the start pointer here, to here at least, so that we get rid of the duplicate character. And for that we need a while loop. So we need to put a while loop while so maybe I can write a bit of code. So while array start in D, move the pointer. I mean s plus equals to 1. So we move, and moving the pointer, as you can imagine, involves removing stuff. So if you move, we're here, moving to the next character, we need to get rid of A. It will move. So here we move to A. If you move to here, and then we realize this, the condition and B is still in the dictionary, so we have to move. Wait. I think I'm. So yeah, it can get easy to mess up. So yeah. So maybe you can just draw a line like this. Okay. And C is still in the dictionary, so we have to move here, and then we remove the character. No, wait, we don't remove it yet, do we? Okay, we are at A, and then we remove A, and I moved here, and then we check the condition is not met because this current character is in dictionary. So we remove that and move to the next one, and the current character, which is C, is still in the dictionary, so we move here. So start pointer, end pointer meets, and then so when we move, we have to remove. Do we have to remove? No, not yet. So the order of things. So another thing to get wrong, another thing that's very easy to get wrong is order of things. So if you put something, if you do the evaluation before moving the pointers and stuff, you can get really completely wrong results, and you might get lost in your thoughts. So here we start from scratch. The maximum is this condition won't be met because C is oh, okay, actually, yeah, since we move from here to here, we have to remove this. Apologies. Move to here, you have to remove C, and now if you move start pointer here, it's not in the dictionary anymore. The dictionary is empty, which is actually not right. Yeah, actually not right, because the dictionary, since we are here, this character should be in the dictionary. Okay, I'm not sure how to do this. This character should not be in the dictionary. How long it has been? Am I spending too much time? So this character should not be. Okay, let me think for a bit. Remove the character, and as we move, okay, so here, when we're here, let's go back and trace this again. Okay, we are here, we had A, B, C. Okay, okay, right. So when we move the end pointer to C, we have to increment the C to to 2. We have to increment C by 1, so it becomes 2, right? So that's what happens when we have S here and E here. Okay, so this will be the dictionary, state of the dictionary, A1, B1, C2. So we just A1, B1, C2, two C's. Okay, so that'll be this, that'll be this. Okay, so and we move to here, so we remove A, and we move to here, we remove B, and we move to here, we remove C, 1C. And so we have to change our base case in while maybe the case change while, okay, so while AR is in D and D dot ARR as more than one, so the number must be more than one. And then so if it's two, if wait no, this won't work. The occurrence is 2, so we move here, we update C. True. So the base condition is not met, so we have to loop until we fix the base condition, in which the current start character not in the dictionary. Or maybe we have to, I don't know. Yeah, this is tricky, so perhaps that's why it's hard. Previous one? That was a medium. Excuse. So what happens when we move the end pointer and start pointer meets at the same place? I don't know. So the base condition has to be changed such that, well, maybe what you can say is and start node equals to end. So this is like only exception. So when start and end is the same, we don't do anything. We don't delete. We just, okay, whatever. So the current value is already in C, but the start and end pointer now is the same. So we don't remove it. I don't know. Okay, this problem we need to fix. I don't know. Okay, let's move on. And then end pointer moves here. Start pointers here. C and B. C1, B1 is fine. And the max is 3, so don't have to update it. It's larger than. And then E moves here. Then there's already a character in B, so the while array dot current character, not the current character, actually you have to consider the, yeah, if we see here, you don't have to only actually consider the current start character. You have to actually consider the ending character. Yeah, so the logic would have been different. So what the logic that I was using is, okay, check the start character if it's already no. Check if the end character that you're currently on is already in the dictionary. If it is, move until. So this is a major mistake. And I did. So this is end character. Check if the end character is already in the dictionary. If it is, reduce the size until. Yeah, okay, so yeah, in this case we have fixed it. So if end character is already in the dictionary, reduce the size of as yeah, reduce the size of and it's more than one or not more than one, not equals to one. Wait. So I'm not sure. Okay, let's go back a bit. So we're here and the value is C1 dictionary C1 and okay here, so I'll show some contrast. So we S is here, E is here. C must be equals to 2. C must be 2. Yeah, because we already add the existing value, so C must be 2. So what do you do while current character is already in the dictionary? No, we can do this. It will be infinite loop. Oh man. It is a hard problem, bro. It is a hard problem. I hope I'm not whispering. Like, my throat is kind of weird at the moment. So this is a really interesting case. So when you're here, start moves here, but your count is 2. While end character. So maybe this is wrong. I'm wasting my time. Why should I spend? Okay, they've stopped watching. Good for you guys. Someone watch my stream for a while. Okay. So someone was on someone was here and they asked like where you get these questions from, dude. So these are questions from something called grokking the interview, grokking the coding interview. These questions are from there, if you must know. So these questions are from there, and I'm not sharing that because there might be some potential copyright issues, so I'm not sharing the actual question. You can look it up. The course is not free, you have to pay and stuff. So I've got some opinions, but I don't want to spend time on that now. Maybe I should reply to him. Seems like we've got a regular. Okay, let's go back to work. Thank you for dropping by. AC Valhalla. I don't know, it's a Assassin's Creed to reference. Unfortunately, I'm not a pro gamer. Not pro gamer, but like I'm not a. I play my Mobile Legends. Anyway, okay, I'm not a. So, yeah, so my area is full of people who like to compensate for these small penises with large exhaust pipes, noisy exhaust pipes. Okay. So yeah, this is it would be interesting if I could solve this. Maybe we can start over. Let's start over. So we got A. Okay, move here, and then the end is already in the dictionary, so we decrement S until. So we move A, and then A would equals to 2. So we're going as E. Okay, so we will have A equals to 2. How we would solve this is the question. It's a base question. So while E is in D and E is more than 1, yeah, this condition, we move S, and we don't need this. You can use this condition, and it's more than 1. Just here it's 2. We move S. So we move from here to here, and then we decrement the value. So A1, and then we stop. And S. Okay, yeah. So that would work. So we just say it's an E. Maybe this would work. So the condition again, while array and pointer in dictionary and dictionary array, the character, the count, the frequency of the character is more than 1, more than or equals to 1. Right. Okay, so this will work when we've already. No. Okay, so this will still work, because every time we see a duplicate, the count will automatically increase to 2, and then yeah, it will work. We solved it. Okay, let's check the solution, even if it's wrong. It's alright. Okay, movement of truth. And we do the maximum non-repeating character. The solution here is much simpler. They didn't change the starting window. Yeah, and even in the solution they're mentioning this is a tricky question. So what it is saying is, if you already see a duplicate character, there's no way like two consecutive. What if it's not consecutive? So here the characters are consecutive duplicates, right? Two consecutive duplicates. What if the characters are like A, B, C, D, E, B? So we get something like this. Here we would have like the longest, but when it enters B, the solution is pretty optimized, perhaps too optimized. So the idea behind is whenever we see a repeated character, we shrink our window size to ensure we all have distinct characters in the sliding window. But that's what we are doing. We're doing a while loop, but they seem to be using some other method to jump the starting window from here to here. So every time you see a duplicated character, you move starting window to the maximum, which is here. Okay, yeah, okay, that would work. So you move on. So let's say the starting window is here, and you go, and then you'll be ending window will be here, and then you see there's a duplicate. What you can do is move this starting window to here straight away. It's probably what they're doing. Probably is not probably a best answer. Yes, I'm using a lot of probably because I'm always taking into consideration the randomness that exists in the universe. So that's why I use a lot of probabilities. Or probably, the word probably. Anyway, there's another question. Longest substring with same letters after replacement. Okay, this is interesting. Maybe should I take a break? Yeah, let's take a break. I'll get some coffee. We're reaching 1 hour mark. It's okay to keep our streams within the 1 hour mark. Okay. See you in a bit. Maybe we could spend some time talking about meta stuff. I don't think we can really avoid talking about the meta discussions because that's kind of adds value, and that's where the real insights are. It's not just about me talking about algorithms and stuff. It's also about talking what are the insights that I'm gaining from actually doing this practice live, and the insights that I'm gaining from it. Yeah, so these have been very helpful. I've mentioned it in my previous streams. Doing these kind of exercise have been really helpful, especially not writing the code. I noticed from watching my previous live streams as an interviewer, when I look at someone straight away jumping into the code without like thinking about the algorithm, that becomes a problem. I logically know that can be a problem, but when I'm like under the stress, I want to figure this out. That doesn't just automatically happen. Um, Automatically come to top of my mind. So recording my attempts and rewatching them have given me a lot more context into the kind of problems that I'm taking and then the approach that I could fix. So right now I'm just thinking about algorithms. Once you have the algorithm in mind, you probably, or in data structure to use an algorithm in your mind, you probably could convert that into code. That's just a matter of proficiency, um, of your programming language, that eventually boils down. There are also some cases of edge cases, that you need to consider when you're translating your algorithm that you've in mind to code, because it's one good example is you can have a lot of suboptimal if analysis in the code. Like there's like if and else, this was it turns out to be not necessary. once once you have that written down, you could probably rearrange the order so that you can eliminate few of the stuffs and redundancies from the code. But that should happen afterwards. Don't think about optimizing or having the optimized code right off the bat. Don't think about like, okay, we've got if here and then we're doing if here and then there's like another if here, so many ifs. And there's another heuristics, like if you got too many ifs, probably you're going in the wrong direction. And that would have been like very obvious in my first video when I was doing the bit switching, if you remember. So you have to read a string of binaries and then flip the binaries or something. So it was related. So I was hard coding the characters, and what I could have done, instead of converting the string integers to numbers, I could have just added them, aggregated them, and do a modulo. Like, so once, if you see a binary 1, add integer 1, and then once the integer increases to 2, you do a modulo of 2, so you'll get a binary number that you want to represent. So you can convert back and forth between number and binary when it's necessary, instead of like hard coding the entire logic. So if you see 1 and 1, then if you add 1 and 1, if you got a variable b, 1 and 1, you add it up, you will get 0 0 1. So you don't have to like hard code that part. I can do some module. So that was another insight that was interesting. And just going through the code, I feel a lot more confident, and probably my confidence will break down when I'm trying to do when I'm actually writing down the code and then submitting to Leetcode. But from what I do, from what I've done so far, I checked the solution. It seems somewhat similar to the idea that I have in my mind. Yes, so these are like a lot of repetition, but I think it's useful and important to repeat these things so that I have this in my mind. Yeah. See you in my next stream. Hopefully I don't spend too much time taking breaks. See you.